Alright, so let's start the demonstration. So this is Blindference and this is our Wave 3 build. For the context, Blindference is a confidential AI execution layer for Web 3. It lets user run AI on sensitive data without revealing that data to the coordinator, while still using a quorum of independent nodes for execution and verification. So I'm going to explain what we actually implemented in this wave, but let's actually see how this demo actually works, right? So first I'm going to connect my wallet to the MetaMask. So I'm going to select my fifth account. Again, my account is connected, so I'm gonna start inferencing, right? So let's see, I'm gonna click on the inference. So in the wave 2, we actually implemented this risk score. What we actually had there is we were able to get this confidential risk scoring using our numerical inputs. But for the third wave, we actually implemented textual inference here, because at the end of the day, we're gonna run different AI agents on it. So we needed this textual inference layer from end-to-end encrypted one for this demonstration and for this particular wave, for our whole prototype, right? So let's try to run a textual inference end-to-end encrypted one. So let's see what is 2 plus 2. 2 plus 2 equals 2, and let's say in complete English. Okay, so what's gonna happen here? Again, this is not a confidential thing, but let's see what it's gonna do here. So I'm gonna run my inference pipeline. So as it's running, I'm gonna explain what's actually happening here. So in this wave, the biggest thing we added is the full confidential text inference. That means a user can now enter a private prompt in the frontend that we entered here. The prompt is encrypted in the browser, uploaded as an encrypted blob to IPFS, and the prompt key is protected with the Kofi and stored on chain in prompt key store. Okay, so here we can see we had a transaction request because we are uploading this prompt key to on chain, and later as our prompt key store contract that is basically deployed on Arbitrum Sepolia, then the ICL, that is inference coordination layer, we're gonna do, it's gonna assign leader and verifiers for this particular compute, and those nodes can decrypt only the prompt key and they're authorized for, and run inference using whatever compute we have, which is using Grok or Gemini for this demonstration, and submit their results back to the quorum flow. As you can see here, the verifiers are waiting for the output of the of the leader node, and after they're gonna be verifying the outputs. As you can see, we are actually comparing the proofs for it that we have they actually computed a correct output. And so yeah, let's wait for it. Also on the output side, the leader will be able to decrypt, leader will be able to encrypt the output key for the users and store it on chain, and only the user wallet can decrypt the final key and reveal the answers in the front end. So as you can see, we actually received the answer here with the commitment that both the verifiers come to the conclusion, and 2 plus 2 equals to 4, and this consensus is actually reached. And this is pretty much the demonstration that we actually showed here. And later on the waves, we will be having the models and nodes here as well. These are for the upcoming waves thing. And for the coverage part, this is again a development from both the Blindference as well as the render team sides. But this will be soon implemented as soon as we get the required credentials as well as our operator ID from the Renera team, and then we can have a full complete coverage. In the later waves, we'll also explore how people will be able to register on nodes, so that we won't be relying completely on these API requests for this demonstration purposes. We'll be having real end-to-end working of these nodes, the compute layer, the coordination layer. So yeah, this is pretty much the demonstration of the wave 3. Yeah, thank you for watching. See ya.